In this video, we're going to explore normal projection. We have a standard grid and it's been subdivided 64 along the X and Y axes, or Z axes in this case. And I've given it some point normals, okay? And just pointing up. And I have this, our demo model from earlier, right? And I have our ray node that we looked at just before. So if I select our ray node, you can see that now we are projecting from our normals all the way up. And when it hits our model, we can actually see the imprint, much like those like toys where you can like stick your hand or your face in and it comes out on the other side, okay? But if we turn off our wireframe and look at our normals, just like with the quarter pipe example, we can just see that it's not actually doing anything to the surface. It still looks flat. It's actually just displacing the points. Now, what we can also do on this node is if we go point intersect normals, so if I click on this button, you can see that like what it's doing now is each one of these points, as it moves up, it hits the farthest point of our demo model. Then it goes, oh, what's the normal on that? And then it like points in that direction, right? So you can see, turn it off, turn it on, turn it off, turn it on, okay? Now, a cool thing is if we say, instead of let's displace the points and not use the normals, we can do it the other way. Let's use the normals, get the point normal, but don't displace the point. So if we bring this back down, you can now see that our object is imprinted on our flat surface, all right? Now, for all intents and purposes, this grid, the subdivision of the grid is essentially, if we think about this as our texture map, each one of these subdivisions is a pixel. So if we increase this to like 128, you can see we're getting more resolution. If we go 256, we're getting even more resolution. If we go 512, we're getting even more resolution. And you can just see now how detailed this is, right? And as we turn on our normals, I'm just going to make them very small, 0.05. And if we go into here, you can actually see how they're averaging over the surface where those points are, right? So you can see it's the same thing as what we've been discussing. It's just happening on a larger scale with many, many, many more points, okay? And if we have a look at this, we can start like rotating this. So we can just, I don't know, like 10 degrees here, and the projection just kind of continues, right? See, as we're doing this, it's projecting. All right, let's go back to how it was. Okay, now you can see that we have like these ugly edges over here. And that's because, again, if we go into here and look at our normals, it's actually interpolating between this point and this point. And you can see that's why we kind of have these nasty edges, okay? And that's why the higher resolution our texture, or our geometry in this case, the better the edges look. But we can actually go in and blur. So if I click on this blur node and I'm just blurring the normals, you can see that it's actually gotten a lot better. So if I put on our normals and then I turn this blur node off, you can see how sharp it is. But then as we blur it, and just see how better the interpolation is, okay? So you can actually see if we just take this and I just up the blur iterations, I mean, it just gets to a point where it's just gonna be like total mush because we're just blurring everything. You can just see how our normals are trying to just, every time we do a blur iteration, it's like kind of averaging the points around it and like reorienting themselves, okay? So that's kind of cool, okay? The next thing I want to talk about is if we now take the direction of our normal, which way it's pointing in world space, and we take that and we put it onto our color, right? So if I do this, you can now see that we're taking the whatever direction our normal is pointing, we're actually converting that direction into color. Now, if you're slightly confused, that's okay. We're going to explore this in a second. But before we go, just want you to just have a look and go and just think about we talk about normal maps, textures, they're like that purpley color, right? And if we look at this, in this current state, this is like green, reds, and blues. All right, so we're kind of going into that direction to understand the normal maps that we put on our game models, okay? And you can see here that if I actually rotate this, so if I go like, 35, you can see how like the color is changed over here, right? And if we put this back to 0, okay, it's like going in weird directions. Okay, you can see how like the colors of the surface of the points change as we rotate our model. Okay, so why is that? So if we go to this box over here, okay, I just have a standard box, and above it I've created an axis. And what I want to do up here, I'm going to click on this, and I'm going to take what we just did on our grid, I'm going to do it onto this box, okay? So what we're essentially doing here is we're taking the direction that our normals are pointing. Let me just make these bigger again. 0.5, yep. So we're taking the direction that our normal is facing, and we're saying, okay, I'm going to apply that to myself, okay? Apply that color to myself, right? So if I take this, we can see that this face is pointing in the X direction, so it's blue. This face is pointing in the Z direction, so this is red. This is pointing in the Z direction, so it's blue, and this is pointing in the Y direction, so it's green, right? And that's just a universal 3D thing. X is red, Z is blue, and Y is green. Now, if we look on the back side over here, you can actually see that these are black, right? Now, why is that? Okay. What is that is in computer graphics, everything going forward is going from 0 and then up. So it's like 0, 1, 2, 3, 4, 5. And then everything going backwards is minus. So this is minus 1, 2, 3, 4, 5, right? Or whatever. Minus, million down there. And the problem is that our monitors can't actually display minus colors, right? So I could take these, and if I just do an absolute value, which is just saying if it's a negative, make it a positive, we can just see that our this is indeed on the x-axis, right? And this is indeed on the z-axis. This is indeed on the x-axis, and this is on the y-axis, okay? Let's turn that off for now. Now, if I take this cube and I actually rotate it, you can actually see as we do this, the faces actually start changing colors, right? And obviously, the reason is because they're now facing this face, instead of facing down the positive z-axis, it's in the positive x-axis, right? And we can do the same here if I do this. Now it's going to change color because now it's pointing in the y-axis, all right? So this is the vertex normals, right? As you can see here. But if I change it to point normal, so if I do this, you could see, because I'm running it over the points, and we're averaging this out, just for explanation's sake here, I'm gonna put it back to vertex normals. But what we're actually doing here is, this is like a weird clown color, and hopefully you can deduce why, is that if this area, let's just turn this off, if this is red, this is blue, and this is green, and we add them all together, red, green, and blue equals white, right? So if we turn this back on, you can see here, because this point over here is pointing in the red direction, in the Y direction, and in the Z direction. If you average those colors together, you get white, okay? And down here, the reason why this is purple down here, let's just do another abs, is that because this is pointing in the X direction, it's pointing in the Z direction, so it's red and blue. And then down here, because this is black, even if we abs it on the point normals, it then goes like red and blue equals purple, right? And you can see here, it's also just adding the purple. And then over here, that's red. And then up here, you can see it's the green and the red makes the yellow, and it only goes yellow until a quarter of the way. Okay, now again, the reason why this is pure green is because these are like negative numbers, so it can't add it, and these are negative numbers as well. And you can see the turquoise because blue and green is this color over here. Okay, so that's what's happening. And again, if we rotate this, you can see that the colors will actually change. All right. Okay, so hopefully you understood that. So now if we go back to here, we turn off our point normals, you can see the reason why this has like all these different colors is because the normals of these, whoa, I'm actually gonna turn this down to like, I don't know, 64. Yeah, there we go, let's do that. So the normals of these are pointing in the different directions and going, okay, well, let's just go like something over here. Like this one over here, it's like it's pointing mostly in the Y. So if we go blue, so blue is that way, and then red is that way, and then green is up like that. So this is pointing mostly in the green, like, and then mostly in the red, and maybe a little bit in the blue. There you go. So you can see it's doing that. Okay. So that's why we're getting these colors when we convert it. Okay. So I'm going to put this back to 256 or 512, because what I want to do next is say, okay, now that we're storing the normal direction, the point normal direction as a color, let's just like reset our normals. Like, who cares? So now if we reset our normals, we actually have no lighting information on here anymore. So I can actually turn on, if I go over here, can turn on a light. There we go, we have a light. Let's go over here. Normal transfer. So we can, we want to go into here. We want to take this, pop this over here. So we do this, okay. See, we have our normal. See, that works nice, okay. And then if we go into here and we say, let's just put our color on, that's fine. And then if we reset our normals, you can see that we have all our color on our points. Like our normal direction is on our points, but we've just removed our normals. And you can see that they're all pointing up. Oh my goodness, 0.05. Okay, cool. See, they're all pointing up. Great, we get it. Nice, move along. So what we can now do is we can go into here. Don't worry about this code, it's fine. We can actually now turn off this color. We won't have to worry about it. But what we can actually do is we can say, okay, let's take our color data, and which is a direction, and convert that back to normal, right? So if we do that and we kind of do this, you can see now we're able to fade in and fade out our normals. So if I do this, you can see it's nothing, right? And then as we do this, you can see how our normals are adjusting. Let me turn off that. There we go, that's probably better. So if we do this, you can see how our normals are shifting. So we're taking that color data and we're shifting it into, we're putting it in our normals, right? So then if I turn off this and I turn this up again, that's the color that we have. And if I blend that out, you can see that's green, and green is pointing up. So that's why our normals are just pointing up. And then as we blend, this is just blending the color in, but then as we blend our normals in, you can see that it's changing based on that. Okay, so you can do that, and then we can do that. Okay, so hopefully you can understand what's happening here when we talk about world space normals, right? The reason why they say world space is because the direction of the points are pointing in world space. So what we're going to do in the next video is take this concept of projection, instead of projecting it onto normals, we're going to project it onto a texture.